This is a very complicated and annoying question, so it's going to be hard for most people, even if we know how to do the algebra correctly. And this might be one of those cases where the algebra solution is faster if you're really good at it. So let's just kind of start down that path, and let me show you what you need to pull out of this question to be able to use the algebra strategy effectively. We're going to need a system of equations, and basically we're going to need two variables for each equation. So we have P for the number or pounds of packages and E for the pounds of envelopes. So we have an equation for A, and that's going to be that 250 times P plus 150 times E is equal to, we got to be careful here, 50 is for A, so that's $50. And then for B, we're going to have $4, I'll put the zeros, I guess, times P plus 50 cents times E is equal to $42. So if those are really naturally coming easily to you, then just continue down this path and solve this way. If it's not, then I'm going to put this on hold and kind of just show you what you could do to still earn these points, because we have a calculator. Guessing and checking here is not so bad. We still need to kind of just keep track of a lot of information, but I would want you to kind of push your way through this and see if you can get it right. So what I would do, this is always what I do, is I try to start with an answer choice that's in the middle. So I usually start with B, and then that way if it's wrong, I can move up or down. And the good thing about B here is it's very much different from the other choices. So if I'm wrong, I'll kind of hopefully know where to go next very quickly. So what is the 20? Well, 20 is the number of envelopes, or the pounds of envelopes, I should say, in this story. So what do we know about them? Well, we know two things. We know if we are dealing with shipping company A, then the pounds of envelopes are going to be 20 times, let's see, A is going to be $1.50 for each pound of envelope. So I have to multiply that. That is 20 times 1.5, and that is $30. Okay, great. What that also means, though, for shipping company A is that we're going to need to get a total of $50 worth of stuff. So I need another 20 to be able to add this up. So, okay, how am I going to get to another $20 if the packages are $2.50 a piece? I'm kind of working backwards here, but basically what we're going to need to do is divide the $20 by 250 and see what that gives us. So 20 divided by 250 is an even number, which is, good sign, of 8. So 8 is the pounds of packages, and 20 is the pounds of envelopes. I got the 20 from the question. The 8 I had to kind of work backwards and solve for. But I don't know if this is the right answer because I need to get these same numbers into the equation or the story for shipping company B and see if they work there as well. So let me show you with a different color here. We're going to do B. We're going to kind of do the same thing. 20 pounds of envelopes. And B says that those are 50 cents a pound, so times 0.5, that I can do without a calculator, is $10. Okay, 8 pounds of packages, those are $4 a piece, that's $32. And if I add those two numbers together, I get 42, which is what I was supposed to get. I have just proven that choice B is the answer because all the numbers worked out. But it was a lot of numbers to work out, so I get why this is very tedious and difficult even with the strategic approach. And that's why I do think if you can manage the algebra, that's probably better here, but it's also difficult algebra, so this is just a genuinely hard question. So let me show you what the algebra would look like. We would need to solve this system. My way of doing it would be to get rid of one of the variables, and I would get rid of the envelopes because it is the easiest thing here to do. So that would require that I multiply the second equation by -3 so that I can start to clean things up and get some even numbers here. So if I do that, let's kind of go off to the side. We're going to have the same top equation, 250p plus 150e is equal to 50, but now I have minus 12p minus 1.50e is equal to 42 times 3 is -126. Now I add these two equations together. -12 plus 250 is going to be -9.5p. The e's will cancel. That was the whole point of multiplying by -3. And 50 minus 126 is -76, which then we have to divide by -9.5 to finally see what the value of p is. And it's 8, which is good because that's kind of what we got before. But notice that's a trap answer there because that is choice A. What we actually need, though, is the value of E. We just found the value of P, but this time it's easy to actually solve for. Just pick one of the equations, plug your P in, and then solve. So I'm going to go back to the original equation where we have 250 times P plus 150e is equal to 50. 250 times 8 is 20 plus 150e is equal to 50. Subtract the 20. 150e is equal to 30. Divide by 150, and we get e is 20, which was the answer we found. Wow, this is really, really hard, and hopefully we can use the calculator in some creative ways when we get into the new SAT, because this is based on a new SAT question, but it could appear on the current form of the SAT as well. And hopefully with the new calculator we'll be able to be really clever, but for now, at least we have the calculator to do the arithmetic portion of this, and there is a lot of it. This happens when we have a lot of numbers, but it also means when we have a lot of numbers, we can often work backwards with those numbers and use guess and check. So it's an option if you need it. Hopefully this helps. It's a doozy of a question.